In number 22, we want to solve this equation for exact values of x over the interval 0 to 2 pi. So we're going to start by subtracting 3 from both sides because we want to isolate that trig function on one side of the equal sign. So we have 4 sine squared x is equal to 4 minus 3, which is 1. And then we'll divide both sides by the coefficient 4. And now we've isolated the sine squared of x. To undo a square, we square root both sides. And the sine of x then is plus or minus the square root of 1 over the square root of 4. The square root of 1 is 1, and the square root of 4 is 2. To get the x by itself, we're going to take the arc sine of both sides, the inverse. So x is equal to the arc sine of plus or minus 1/2. So we're looking for the angles on our unit circle that have a y coordinate of 1/2. And in our first quadrant left-hand trick, sine is the fingers underneath, so we bend this one, and that's our pi over 6 angle in quadrant 1. So our first angle is pi over 6, and that has a sine of 1/2. It's positive 1/2 in quadrant 1. Sine is also positive in quadrant 2, so we reflect that angle into quadrant 2, and we're at 5 pi over 6. Sine is negative in quadrant 3, so we reflect pi over 6 into quadrant 3 to get 7 pi over 6, and then sine is negative in quadrant 4, and so the negative 1/2 would be at 11 pi over 6. So our 4 solutions over the interval 0 to 2 pi are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And to check those answers, we're going to store them one at a time in the calculator. So we'll start with pi over 6, and we'll store that as x. And then we're going to enter our original equation, 4 sine of x squared plus 3. And second math gets us the test menu. Number 1 is the equals, and then our 4. When you use the equal sign from the test menu, you're asking the calculator a true or false question. If this is true, the calculator replies with a 1. If it's false, it'll reply with a 0. So we'll press enter, and we get a 1, so it checks. Next, we're going to check 5 pi over 6, so we'll store that as our new x, and then arrow up to the equation, press enter, and 5 pi over 6 also checks. Next, we'll do 7 pi over 6 as our new x, and again we get a 1, and then 11 pi over 6. That's our quadrant 4 answer, and we get a 1. So we know that all 4 of those solutions check.